Hello friends, welcome to HPC Diamond Academy. In the last lecture, we have discussed in detail about the surface integral. So in this particular lecture, we will discuss about the problems on the surface integral. So let's start our discussion. So what we have seen in the previous set of lecture is that any surface phi in terms of xyz represents a surface in a 3D space. Okay. So and the general form of the surface integral is in this form. Double integral along the surface as f dot n cap into ds. This is the basic form of the surface integral. Okay. So for finding the expression f dot n cap ds, we take the projection along the region R. This gets converted into f dot n cap into how we find the ds. This ds is basically for finding the value of ds, we take the projection of the surface. Suppose we have a function phi in terms of x y z z. Suppose this is our surface, our curved surface, our surface S. So for finding the value of ds, we take the projection of this curved surface plane. Let us consider this is as a xy plane. This is our xy plane. Let us suppose we are taking the projection of this surface S on xy plane. Whenever we are taking a projection, the xy plane is a planar area. Planar area. Let us consider this as a region R. For finding the value of ds, we take the projection of this curved surface on this plane, that is xy plane. So we can take the projection in any of the plane based on the demand of the question. Suppose we are taking the projection on the xy plane, then this curved surface gives the projection on xy plane as a planar area. So we have this as let us consider this elemental region as dr. Then we have ds cos gamma. ds cos gamma is equal to d. From here we have ds is equal to dr upon cos gamma. How we can find the value of cos gamma? We have the outward normal, unit vector along the outward normal as, and unit vector perpendicular to this xy plane. Unit vector perpendicular to xy plane is k cap. Angle between angle between n cap and k cap will be gamma. So the cos gamma will be, this is equal to dr upon cos gamma will be cap dot. This is the value of ds. Similarly, if we take the projection of this surface on, we take the projection of this surface on xz plane, this then this will also give a planar area. Suppose this is our region R dash, our region R dash. This is the projection of the surface S on xz plane. How we can find this? We have ds is equal to R dash upon cos gamma. This is equal to dr dash upon cos gamma. How we can find? This is dot product of n cap. N cap is unit vector perpendicular to this surface S. Dot product with, since we are taking the projection on xz plane, so we have the unit vector perpendicular to the xz plane is this is j cap, n cap dot j cap. Similarly along the yz, so along the yz, if we are taking the projection on yz plane, then we have the value of ds as this is dr double dash. Suppose this projection is r dash, so r double dash upon n cap dot unit vector perpendicular to yz is mod. So this we can write as so suppose the projection is on xy plane, then dr gets converted into dx dy upon n cap dot j cap. Similarly, in case of when the projection is on xz plane, then this is equal to dx dz upon cap dot j cap. Similarly, on yz plane, this is dy dz upon n cap, dot product of n cap with unit vector perpendicular to yz plane. Unit vector perpendicular to yz plane is I cap. Let us summarize this. After that, we will start the solving the questions. Okay. We have when the case 1, when projection by plane. Case 2, projection by z plane. Case 3, zx plane. Let us find the value of ds. What is the value of ds? When the projection is on xy plane, let us draw the diagram also. Ease of understanding. Let us draw the diagram also. Let us consider this surface like this. When we are taking the projection on xy plane, our planar area will give a planar area like this. Our region x and this is y. Value of dr will be dx dy. This is equal to the value of ds will be dx dy upon unit vector perpendicular to the surface is n cap, and unit vector perpendicular to this region r region r vector perpendicular to this region r is k cap. The dot product of n cap with k cap. Cap dot k cap का mod. Similarly, for when the projection is on yz plane, y and this is z, this will be equal to s is equal to dy dz upon cap dot. So we have the we have to take the dot product of n cap with unit vector perpendicular to this yz plane. The unit vector perpendicular to yz plane is along x-axis, that is I cap. Similarly, for case 3, we have ds as when the projection is on xz plane. Suppose this is the projection is like this. Projection is this of this curved surface on xz plane. This will give a planar area like this. Our, let us say this as region r dash. R dash will be dx. D of r dash is dx of dx dz. We have this as dx dz upon cap dot. We have the unit vector perpendicular to xz plane. Unit vector perpendicular to xz plane is along y. Y is j cap. This is basically okay. So these are the cases for finding the value of ds based on the projection, whether we are taking on xy plane or on yz plane or on xz plane. Okay. So this is the basic concept of the surface integral that we have revised. So let us start discussing the problems. Let us discuss question number 1. Okay, so what is given in question? Evaluate f dot n cap ds, where f is equal to yz I cap plus zx j cap plus xy k cap. S is that part of the sphere of the surface. Sorry, S is that part of the surface of a sphere x square plus y square plus z square is equal to 1, which lies in the first rectangle. Let's solve this question. How we can solve this? Okay, so we have to evaluate f dot n cap ds along the surface. So the surface is square plus y square plus z square is equal to 1, which lies in the first rectangle. Have our let's take this as coordinate axis. This is x, this is y, and this. We have to take the that part of the sphere which lies in the first rectangle. This is our first rectangle. Draw the sphere. That part of the sphere that lies in the first octant. Six. When so the surface is, let's consider this as phi. Phi is equal to square plus y square is equal to square plus y square plus z square. Our surface. The equation of a sphere is x square plus y square plus z square is equal to 1. Let's draw the, let us write down the coordinates. We have this as, since the equation of a sphere is x square plus y square plus z square is equal to 1, so the coordinates will be 1 comma 0 comma 0, 0 comma 1 comma 0, 0 comma 0. Okay, so we have to find the value of f dot n cap ds. How we can find the value of n cap? Let us find the value of n cap. Okay. We have cap is equal to del of phi upon mod of del phi. Let us find the value of del phi. So del of phi is equal to I del upon del x, j del upon del y, plus k del upon del z of phi. So of phi is x square plus y square plus z square equal to 2x I cap plus 2y j cap z k, the value of del phi. Let us find the value of n cap. So n cap is equal to del of phi upon del phi ka mod equal to 2x I cap plus 2y j cap plus 2z k cap upon 4x square plus 4y square plus z square ka. Okay, so this will be equal to x I cap plus y j cap plus z k upon, let's take 2 outside. Outside we have 2 times of square plus y square plus z square 1. So we have the value of n cap as cap is equal to x I cap plus y j cap plus z k. Okay, so we have the value of n cap as x I cap plus y j cap plus z k, the value of n cap. Okay, now let us find the value of ds. Okay, so for finding the value of ds, let us take the projection. So this is our curved surface. This is our curved surface. So we take the projection of this curved surface on the xy plane. So the surface S gets transformed into a region R. This is our surface. Since we are taking the projection of this curved surface on the xy plane, so this is our region R. This is our surface. S, and this is our region. Let us draw the region R. We have the region R as x. This is y. Our region R. This is 1 comma 0 comma 0. This is 0 comma 1 comma our y and z. Okay, so this is our projection. So this is our region R. So here the value of x varies from 0 to 1. Okay. Let us take a strip like this for finding the double integral region R. X varies from 0 to 1. This y varies from 0 to. So we have the expression as expression of this curved surface as square plus y square. Since z is equal to 0, square plus y square is equal to 1. So from here the value of y is equal to 1 minus x square. The value of this will be, value of y will be 1 minus x square root. So x varies from 0 to 1, y varies from 0 to under 1 minus. Now let us find the value of this expression f dot n cap ds. So we have the value of f as f is equal to f is equal to, let us rub the unwanted things that we have written here. We have the value of n as, so we have the value of n cap as x I cap plus y j cap plus z k cap. We have the value of f as f is equal to z I cap plus zx j y k cap. Yeah. and we have to find the value of ds. So we have the value of ds as, since we are taking the projection on the xy plane, so this is equal to dx dy upon dot product of n. This is our n cap dot product of n cap with, since we have taken the projection on xy plane, so we have to take the dot product of n cap with unit vector perpendicular to this region R. So the unit vector perpendicular to this region R, which is a planar surface, is along Z. So this is k cap, n cap dot k cap. So we have this as dx dy upon, we have the n cap as this one, cap dot k cap is, okay, this is the value of ds. We have calculated ds, n cap, and value of f is given in the question. Let us put here. So we have the value of surface integral as f dot n cap ds is equal to, f is this one, this is yz I cap plus zx j cap, zx j cap plus xy k cap dot of n cap is x I cap plus y j cap plus z k cap. Value of ds as dx dy upon z. Okay. So let us take the dot product of f. This is our f, this is our n cap, this is our ds. As simple as that. Let us take the dot product of f and n cap. This is, let us multiply the terms containing I. This is xyz, xyz similarly plus xyz plus xy upon z dx dy. Integration along the region R, and region R is this one. Region R is, this is our region R. Okay. Let us find the value. So this is 3xyz. This is equal to double integrals along the region R. 3xyz upon z dx dy. Z gets cancelled, equal to double integration along the region R. This is 3xy dx dy. Okay. Let's integrate this. We have this as, so here let us put the limits. So we have the value of x varies from 0 to 1, equal to 0 to 1. Y varies from, so we have taken the vertical strip. This value will be 1 minus x square, because the equation of this curve is x square plus y square is equal to 1. So from here we have y is equal to 1 minus x square. This strip moves in this pattern. Whenever we move this strip in this pattern, it will cover the whole region R. Y varies from, so here we have y is equal to 0, here we have y is equal to 1 minus, here we have y is equal to 0 to 1 minus square root. Just solve the integral for getting the answer. We have, let us take this as, let's take this value as I. So we have the value of I is equal to 3 times of double integral 0 to 1, 0 to 1 minus x square x d. So let us first y is equal to y, x is equal, I is equal to 3 times of 0 to 1. This is y square by 2, y square upon y dy, 1 minus x square root. We have this as I is equal to 3 upon 2 x into 0 to 1. Okay. This is equal to upon 2 equal to 3 upon 2 x dx square by 2 4 upon 4. Limit is 1 and 0. 3 upon 2, 1 upon 2 minus 1 upon 3 upon 2, 1 upon 4. 3 upon 8 is the value of this expression. F dot n cap ds is 3 upon 8. Let us discuss question number 2. let us discuss question number 2. So in the first case, the answer is 3 upon 8. So in the second case, we have second question. We have evaluate f dot n cap ds, where f is equal to z I cap plus x j cap minus 3y square z k cap, and s is the surface of cylinder x square plus y square is equal to 16, included in the first octant between z is equal to 0 and z is equal to pi. So let us draw the cylinder, the first octant. Let us draw the xy plane first. Our sorry, this let us draw the coordinate axis. X this y. So let us draw the cylinder. Our cylinder in the first octant. Okay. And this is between the plane z is equal to 0. So this is z is equal to 0. Xy plane is z is equal to 0. This is z is equal to 5. So this plane is z is equal to 5. Value of z varies from 0 to 5. Let us take the find the value of this integral. Okay, so we have this as f dot n cap into ds, double integral. Let us find the value of s. So we have let us find the value of d n cap. How we can find this? This surface is x square plus y square is equal to 16. So let us find the value of, we have the, let us consider this surface as phi. We have phi is equal to x square plus y square. Okay, our surface. Let us find the value of n cap. N cap is equal to del of phi upon del phi. Del of phi gives the outward normal. N cap del phi upon del of phi mod gives the unit vector along the outward normal. We have the value of del phi as del phi is equal to I del upon del x j del upon del y to phi. Phi is x square plus y. This is 2x I cap y j cap upon the root of x whole square y whole equal to 2x I. Let us take 2 outside. X I cap plus y j cap upon times of square plus gets cancelled. This is equal to x I cap plus y j cap long upon x square plus y square is equal to 16. So this is the value of n. We have the value of n cap as, let us write down here. We have the value of n cap as x I cap plus y j cap upon. Okay. Now let us find the value of ds. How we can find this? Okay, so this is our surface of the sphere. Okay. So for finding the value of ds, we have to take the projection on xz plane. This will be our region R. This is our, let us draw it again. We have the sphere like this. This is our curved surface. This is our curved surface. We are taking the projection on this xz plane. We have this as x, this y, and z. We are taking the projection on this xz plane. Our region. Let us find the limits on the value of x and z. X varies from, we have this as equation as x square plus y square is equal to 16. So we have this as 4 comma 0 comma 0. This is z is equal to 0. Have this as 0 comma 0 comma z varies from 0 to 5. What is the value of this point? This point is 4 comma 0 comma 5 on the xz plane. So this is our xz plane. xz plane is like this. X, this region R. Region R is like this. Okay. X varies from, so here x varies from 4 comma 0 comma 0, 4 comma 0 comma 5, 0 comma 0. X varies from 0 to 4, and z varies from 0 to, okay. Let us find the value of integral. So we have the value of ds as, so ds is equal to since we are taking the projection on xz plane, so dx dz on n cap dot unit vector perpendicular to this region R. Since it is yz plane, sorry, this is xz plane, this is xz plane. Unit vector perpendicular to xz plane is uh, along y. Along y we have j cap. This is equal to, so ds is equal to dx dz upon n cap dot j cap, y upon 4. So dot product of n cap with j cap, so this is y upon dx dz. Now let us find the value of integral. So we have double integral f dot n cap. We have the value of n f as z I cap plus xj, z I xj j cap 3y square z, 3y square z k dot n cap is x I cap plus I cap plus y j cap upon 4 f dot n cap into ds. ds is 4 dx dz y. Okay, and this is region R on the since we have taking the double integrals along dx dz. So we have the limit on x. So x varies from 0 to 4. X is equal to 0 to 4. Y is equal, and z varies from 0 to 5. This is the limit on z. Z is equal to 0 to 5. Let us further simplify this for getting the answer. This 4 gets cancelled. So we have this as xz plus dx double integral equal to 0 to x equal to 4. Y z is equal to 0 to 5. Y. We have this as I is equal to 0 to z is equal to 0 to 5. Z upon y plus dx dz. Let us place the value of y. So we have the equation as x square plus y square is equal to 6. So from here y is equal to 6 minus x. We have this as xz upon r plus x is equal to 0 to 4. 0 to 5. So I is equal. Let us take this as integral. Let us take this as I1 plus I2. I1 plus I2. I is equal. So value of I1 is x is equal to 0 to 4. Z is equal to 0 to 5. This is x z z dx dz. I1 I2 is equal to x dz per under double integral x is equal to 0 to 4. Z is equal to. Let us find the value of these two integrals and After addition, we will get the so we have the value of I1 as I1 is equal to 1 z dz integral. The value on x is equal to 0 to 4. Limit on z is equal to 0 to we have the value of I1 as let us take 16 minus x square is equal to p square. From here minus x dx is equal to minus 2x dx is equal to 2x dx is equal to minus p. Okay. So we have this as minus dp on root under 16 minus x square is equal to z dz. When value of when x is equal to 0 from this expression x is equal to 0 equal to 4. When x is equal to 4, this is this gets cancelled. The limit p is equal to 4 to 0. Okay. And z limit is 0 to 5. I1 is equal to 0 to 5. This is minus sign, so we can reverse the value of limit. So 0 to 4. This is dp. This is dp z dz. This is the integral of dp is p. The value of limit is 0 to 4. This value is 4. This is I1 is equal to 4 times of z dz is z square upon 2. Limit is 5 and 0 equal to 4 into 5 square upon 2. 25 upon gets cancelled. 50. Value of I1 is 50. Now let us find this one I2. Sorry, here the value of I2 is here the value of I2 will be x dx dz equal to 0 to 4. Z is equal to 0 to 5. Value of I2 will be this is x square upon 2 x ds. Integration of x ds is x square upon 2. Limit is 4 and 0. So dz is equal to 4 square upon 2 dz. The integration of dz is z. Z limit is 0 to 5. This is will be equal to 16 upon 2 equal to 40. The value of I is I1 plus I2. This is equal to 50 and this is 40. 50 plus 40 equal to 90 is the value of the integral. This is question number 2. So let us discuss question number 3. Okay. So question number 3, we have to evaluate f dot n cap ds, where f is equal to x plus y square I cap minus 2x j cap plus 2yz k cap, as is the surface of the plane 2x plus y plus 2z is equal to 6, which is in the first octave. Let us draw this plane first. We have the plane as plus y plus z is equal to 6. So from here we have x upon 2x upon 6. So 3 plus y upon 6 plus z upon 3 equal to 1. So let us draw this plane. This is plane is like this. This is 3 comma 0 comma 0. We have the value of y as 0 comma 6 comma 0. This is 0 comma 0. This is our plane. Let's draw the plane. Okay, so this is our plane. Let us find the value of n cap. So n cap is unit vector along the outward normal. Outward normal is del of phi. So unit vector will be n cap is equal to del of phi upon mod of del phi. Okay, we have the value of phi as this one. Let us find del of phi. Del of phi will be I del upon del x plus j del upon del y plus k del upon del z. This is 2x plus 2 equal to phi cap plus cap plus 2. Okay, equal to 2 I cap plus j cap 2k upon 4 plus 1 plus 4 I cap plus j cap plus k cap upon 3. Okay, this is our n cap. N cap is 2 I cap plus j cap plus, this is the value of n cap. Now let us find the value of ds. Let us find the value of d. Okay, so for finding the value of ds, we have to take the projection of this surface. This is a planar surface. Take the projection of this surface on xy plane. So our region R will be our region R, that is on xy plane. This region R will be like this. X, and this is 3 comma 0 comma 0 0 comma 6. How we can cover this whole region? So we have to take the strip like this. If we vary this strip the y direction, if we move this strip in y direction, then this will cover the whole area. So here x varies from, we have the equation of this as, the equation of this is z is equal to 0. So this is x plus y is equal to 6. So from here the value of x will be 6 minus y upon, x varies from 0 to 6 minus y upon 2. Y varies from, this strip moves in this particular fashion. This strip moves in this particular fashion. So the y limit will be from, 0 to, y varies from 0 to 6, x varies from, because here we have x is equal to 0, here we have x is equal to 6 minus y upon, this is the limit on the integral, that is on the integral along the surface R. Let us find the value of this integral. This is f dot n cap ds. We have this as, value of f is x plus y square. We have f dot n cap ds is equal to, the value of f is x plus y square I cap plus y square minus x j cap plus 2yz plus yz k f dot n cap. N cap is this one, cap plus j cap plus cap upon f dot n cap into ds. Okay, so how we can find the value of ds? Since we have taken the projection on xy plane, so ds is equal to dx dy upon n cap dot unit vector perpendicular to this region R. So this is region R. So region R is our region R is on the xy plane. So unit vector perpendicular to xy plane is along the z axis, that is k cap mod. Let us take the dot product of n cap with k cap. So this is our n cap. N cap with k cap will be 2 by 3. So dx dy upon 2. This will be equal to 3 upon 2 upon 2 dx d. Okay, let us find the integral. This is region R. The simply x varies from 0 to 6 minus y upon 2. The value of y varies from. Let us further simplify this. This is equal to along region R. This is equal to, this gets cancelled, 1 upon 2 x y square minus with j cap 4yz. Okay, 2 times of 2x plus 2y square minus 2x plus 4yz dx dz, sorry, dx dy upon 2 half is there. This gets cancelled. Here, from here we can take 2 outside. I is equal to y square plus dx dy equal to double integral. Here we can take y outside. Y plus z. We have the equation for the surface as x plus y plus z is equal to 6. We have to replace the value of 2z. So z is equal to, from here 2z is equal to 6 minus 2x minus 6 minus 2x minus y. Let us place here I is equal to double integral y times of y plus minus 2y dx dy. This gets cancelled. Y times of 6 minus 2x dx dy. Let's further simplify this. Along the region R, have the value of I as y times of 6 minus 2. So along the surface, along the region R, we have the value of y varies from 0 to 6. 0 and y varies from 0 to 6, x varies from. We have taken the strip like this. This equation is 2x plus y because z is, so we have the plane as equation of plane as 2x plus y plus 2z is equal to 6, z is equal to 0. So we have this equation as equation of this line as 2x plus y is equal to 6. This value of this will be, we have taken the strip in this manner. Here the coordinate of x will be 6 minus y upon 2. X varies from 0 to 6 minus y upon 2. So here we have x is equal to 0 to minus y upon 2. Y is equal to 0 to 6. Let's further simplify this. Okay. So how we can, let us solve with respect to x first. This is equal to y times of minus 2x square by 2. This x square. Limit is y is equal to 0 to 6. I is equal to sorry, not the limit we have already placed. Y is equal to 0 to 6. This we can solve like this. Let us take x outside. Y times x, 6 minus, limit is 6 minus y upon 2. I is equal to y times of 6 minus y upon dy. This is 0 to 6. This will be equal to I is equal to y times of 6 minus y upon 2. This is 6 to the 12 minus 6 plus y upon dy. Value is 0 to 6. Okay. Value of this is, value of I is equal to half. This is 1 upon 4. 1 upon 4, 36 minus y square. Y times of 36 minus y square dy is 0 to 6. Okay. I is equal to 1 upon 4. 36y minus, sorry, this is 36y minus y cube into dy. This is 0 to 6. I is equal to 1 upon 4. 36y square upon 2 minus y 4 upon 6, and okay, whole bracket is 1 upon 4. I is equal to 1 upon 4. 36 square upon 2 to the 4. I is equal to 1 upon, this is the power 4. This is 36 and 6 square. So this is also 6 upon 4. 6 to the power 4. Power 4 we can take out, and this 1 by 2 minus 1 by 4. 1 by 4. This is 36 into 36 on 4 for the 16. 4 into 4. 9 into 9. Okay, so this is the solution of question number 3. Okay, so we have discussed up to question number 3. Similarly, you can find the question number 4 also. Okay, so this is similar to question number 3. So here S is the surface of the plane 2x plus y is equal to 6 in the first octant. Okay, it is cut off by the plane z is equal to 4. Okay, so this plane is perpendicular to the xy plane. This is 2x plus y is equal to 6 is perpendicular to the xy plane. Okay, so we cannot take the projection on xy plane, so that's why we have to take the projection of this plane on the xz plane. So on taking the projection you can find the solution. Let us give I will give some hint also, but it is here for you to. Let us analyze this, otherwise it will be a problem for you. Number 4. So if evaluate f dot n cap ds, where f is equal to phi I cap plus x j cap minus z k cap. Okay, where s is the surface of the plane 2x plus y plus 6 and first octant cut off by plane z is equal to 4. This is our coordinate axis x, this is y and z. Let us draw the plane 2x plus y is equal to 2x plus y equal to 6. Have this as plane as 2x plus y is equal, you can write as x upon 3 plus y upon 6 equal to 1. Coordinate is 3 comma 0 comma 0. This is, so this plane is this plane is perpendicular to the xy plane. This plane is like this. perpendicular to the xy plane. So something that is perpendicular to the xy plane, we cannot take the projection of this plane on xy plane. So we have take the projection of this plane either on the xz plane or on the yz plane. So the projection will be this one. If we are taking the projection of this surface on xz plane, so this will be our projection will be like this. This is our x and this is our z. This is our projection. This is 3 comma 0. This is z is up to z is equal to cut off by s is the surface of the plane in the first octant, cut off by the plane z is equal to 4. This is our z is equal to 4. Z is equal to 4 plane. This is our plane that is perpendicular to xy plane and it is cut off by a plane z is equal to 4. So z limit will be from z is equal to 0 to z is equal to 4. This is our, and we have taken the projection of this xy plane on xz plane. This red marked portion is our region R. This is our region R. This coordinate is 3 comma 0 comma 0. Z is 0 comma 0 comma 3 comma 0 comma. This is our region R. Our region R. Okay, so the limit on x will be, x limit is 0 to 3, z is 0 to 4. How we can find the value of n cap? N cap is equal to 2y cap. Directly we can write del of phi upon del phi mod. Y cap plus j cap upon 4 plus 1 under root is 2 upon root under 5 I cap plus 1 upon root under 5 j. Okay, this is the value of n cap. Let us find the value of ds. ds is equal to, so since we have taken the projection on xz plane, so this is dx dz upon n cap dot unit vector perpendicular to this xz plane. The unit vector perpendicular to xz plane is j cap. So n cap dot j cap, this is 1 upon root under 5 dx dz. So we have the value as f dot n cap ds. We have the value of f as this. We have the value of n cap as this. We have the value of ds as this. Let us place this. So we have this as f dot n cap ds. So let us take this as I. This is y I cap plus x j cap z cap f dot n upon root under 5 plus 1 upon root under 5 j ds. So ds is root under 5 dx dz. Root under 5 gets cancelled. This is equal to 2y plus 2 x dz. Let's take 2 outside times of x plus y dx dz. Let us put the value of y in terms of 2x. From here we have y is equal to 6 minus 2. Let us place here. We have this is x plus y. This is y. Sorry, this is after taking 2 outside. This is y plus x. Value of y is 6 minus 2 plus x dx dz. Okay. We have taken 2 outside. Let us write down one step also. This is equal to 2 outside. This is y plus x dx dz. Since the integral is in terms of dx dz, so let us place the value of y as 6 minus 2x. This is equal to 2 times of y is minus 2x plus x dx dz. This is equal to 2 times of double integration. This is 6 minus x dx dz. X is from 0 to 3 and z varies from 0 to 4. This is the value of integral. Let us find the value of I. Let us further simplify this. I is equal to 2 times of this 6x minus x square upon 2. Limit is 0 to 3 is dz. I is equal to 2 times of 6 into square upon dz. Value of dz. The integral of dz is z, so this is equal to 4. I is equal to 8 times of 3 is 18 minus, this is, let us take 9 outside. I is equal to 8 into 9 minus 1 upon 3 upon, let's cancel into 3, 108. 108 is the, okay. So we have discussed total 4 questions on the surface integral. Thank you.